Okay, so this is the beam right here. Everything. This is the system, I should say. And before I start, everything is in equilibrium. That's why I set these equations to 0. I'll get to that in a little while. So it's not moving. Everything's in equilibrium. So this is the whole length, 5 meters. This is the distance from the wall to the object. And we have a force being applied from the wall onto the beam. This is the cable. It has tension in it. And these are the two gravitational forces exerted on the mass. So that's why these are moving downward. Okay, so I broke this up into x and y components. You see the x component, t cosine theta. It's adjacent to it, so it's cosine. T sine theta, it's opposite of it, so it's sine. And it's minus these two because they're traveling in the negative y direction. So these are the equations that I came up with. The x component of the force subtracted from t cosine theta, and the y component of the force subtracted from these two because they're moving in the negative y direction, and I'm adding it to t sine of theta because it's traveling in the positive y direction. Now, because I picked this point about which to find my torques, I do not have to worry about the x or the y component of the force. Okay, so because of that, I can go straight into finding the tension. Okay, so I'm going to use the torque equation. Okay, so this is the perpendicular force, and that's its radius. So the perpendicular force, t sine theta. Okay, this is the flat surface. It's perpendicular to it between the axis and my application here, the middle. So that's why it's perpendicular, and it's multiplied by the whole length. Then, of course, I subtracted the M1G again. It's negative y direction, and I multiplied it by the L2 because M1G is the perpendicular force of this length divided by 2. And it's divided by 2 because if that's the middle, then you got half of the length on this side, the other half on this side. So it's divided by 2. Let's see. Okay, and then of course I subtracted that from the M2G multiplied by this distance, again because this is negative y direction, but also because this is a perpendicular force to the flat surface, and it's going to be multiplied by its radius from the wall to this object, which is just 1 meter. And it's all equal to 0. So now in these next two steps, as you can see, I'm just trying to isolate the tension, get the tension by itself. I moved everything over, and eventually T is by itself, and this is how the final would look. And this is the math for it. This is just the math for it. And the tension is 2,195.2 newtons. Now, since we have the tension, now we can find out the x and the y component of the force. So for the x component of the force, I'm just referring back to this one. I get it over by itself. This is the math for it. X component of the force is 1,901 newtons. And then for the y component of the force, again, I'm just isolating the y component of the force, and I'm moving everything over to the other side. It basically just changes signs, and this is the math for it. And the y component of the force is 1,450.4 newtons.